1, the greatest competition. Cars designed and engineered by the brightest minds, driven to the edge by the world's chosen few. Teams rise and fall, drivers come and go, but echoes of the past and aspirations for the future always remain. New hopes rise as a new season comes. New cars, new engines, and drivers strive to drive faster than anyone else to achieve the pinnacle at motor racing's highest tier.
Welcome to the Development Corner. This is Sam Choi, and I would like to introduce the aerodynamics of racing car. Aerodynamics is separated by two main parameters: action, force, and drag. Aerodynamics is one of the key factors of modern aircraft and modern car design. For improving the aerodynamics effect on racing car and aircraft, wind tunnel can simulate the scenarios and improve the airflow through the chassis and the car part itself, in order to generate more lift force or downforce. Due to the limitations on the FIA regulations, F1 teams are only allowed 60 hours per week of wind tunnel running time, due to the cost cap policy. Also, the car used in the wind tunnel is limited under 60% of the scale to the real Formula 1 car. Meanwhile, in the track running time, aero paint can be used to clarify and show the airflow on the car, and that can be used as comparison back in the factory for reference, in order to prove the modified components are improving the performance of the car. CFD, Computational Fluid Dynamics, is the third method to simulate the aerodynamics performance of the F1 car. This provides the foundation of aerodynamics data without the need of manufacturing a real component. With all the simulation and running time, now the modified part can be produced according to the data. In this scenario, Ferrari has increased the flaps on the main plate and the 3-element cascade front wing to generate more downforce. Here is the introduction of vortex. Vortex is one of the most interesting parts on aerodynamics. They can be captured by slow motion camera, and they will only appear in humid conditions. Vortex is an area of revolving compressed air. The compressed air, which is the turbulent air, build a combination of small vortices. Usually, small vertical wing or winglets are the vortex generator. Its purpose is to re-energize the boundary layer and thus increase the overall velocity of the air stream. As the comparison, Ferrari have a much bigger radius of vortex generating and redirection outside of the chassis surface, whereas the Red Bull has a really tight vortex and is able to have a coanda effect where it sticks to the shape of side port and channeled to the rear brake duct and the diffuser to gain further downforce. This is a closer look on the Red Bull engineering. Elegance vortex, elegance aerodynamics effect, gain much downforce as it can, to generate much more grip. However, more downforce means more drag, which compromises the top speed. However, it will increase the corner speed. That's why the well-designed Red Bull car won the championship in 2013. Now to the drawing board. Aerodynamics is one of the most complex subtopics of fluidodynamics. Firstly, I introduced this lift force generated airflow. With the air flow through the airflow, always there will be some swirling of turbulent air at the back of the wing, and before the smooth air hit the wing, that's called the lambda, and the back of it, which creates vortex or turbulence, and that will be called the turbulence air. And in this case, lift force and drag can be calculated by the formula of F equal P times A, or P equal F over A. Pressure differences between two surfaces of an object create a force from high to low pressure because the pressure equal to them. To identify where the area of high and low pressure, the air traveled faster above the ground created an area of low pressure. Alternatively, Slower air below the wing creates a high pressure area. The airflow above will separate toward the back and create turbulence air, and affect lift and drag force. Because of the lift force overcome the drag force, so that lift force created by this wing. And that is how the aircraft flies. Then when you turn it upside down, and that is how the mechanism and the physics of Formula One car created downforce, with the wing upside down, to generate more grip and better downforce, which means better cornering speed and better exit and more drivability. And thank you to listening to my presentation. Enjoy the montage.
What is so important about driving faster than anyone else?